Hi, I'm Eun-Chul in Gongju National University, South Korea. I'm very happy to see you all guys through this video lecture. Today, prepare this video lectures for the how to download, install, and do the test run for the semi-Lagrangian version of the IsoGSM. Currently, the IsoGSM itself, we can download the source code from the CVS server. But for the semi-Lagrangian version, I uploaded and managing all the source code and all the components in the SVN server, which is the managing in my laboratory. So simply prepare. I'm gonna tell you about the every procedures about this for the semi-Lagrangian version of the IsoGSM. So I guarantee if you simply following these procedures in this video lectures, maybe you can do all these things without any kind of serious trouble. So please enjoy these lectures. And for the before we're gonna start the lectures, there's one person to I wish to introduce you to all you guys. This guy is the person who actually updated this semi-Lagrangian to the IsoGSM. So let's check it out. Okay, so this is the guy I just introduced. This is the guy they actually do all these things. So
Hello, I'm Namgoyo from National University. If you have any questions for installing GRSM, contact me. Thanks.
Alright, so let's just start from the download this semi-Lagrangian version of the IsoGSM. I just log into the isotope 2 server. If you are using the Linux system, maybe the fundamental procedures are maybe identical. So first time in this lecture, I'm gonna use this isotope 2 system for this lecture. Alright, so first moving to some subdirectories. Let's take a 7 and Eun-Chul. This is my directory. So if you want to, if you have some permission to access to the isotope 2 server, maybe you can see inside for the reference. Okay, so before first I'm gonna make this GRSM directory for this directory. Oh, and I'm already made it this. Okay, so inside of this GRSM directory there's nothing. So the first command is make download from the SVN server. This SVN CO, the checkout, and give some the IP address for this SVN server. This is the address for the SVN server, and specify the repository name. The repository name is GRSM, and the next thing we have to specify is the item name. The item name is IsoGSM. Okay, so with this command, when enter, maybe we can access to the SVN server. Then this server will ask you about the password for this login name. For this case, Eun-Chul is the login name of this Linux server, not for the SVN server. So just SVN server think these users just gonna try to log in with the same login name of the local server now. in this case, this local server is ISO2. So but definitely I'm not gonna using this login the ID in ISO2. Just I'm gonna use the different the username for the SPN server. So here just do not type anything and just type enter. Then the server will ask you again for the username for this SPN server. For the users, the username is the guest, and then the server will ask you about the password for the guest. For this the password for this guest, if you want to access to this ID, just contact me or contact the Professor K. Yoshimura, and maybe we can provide the password for all the packages and code. Okay, so when you type the right password for this guest ID, the server will ask you about you will gonna save your password into the local system. So maybe if you type no, maybe the next time you try to download this code again, then the server will require the password again. But the store password for the encrypted means after this step, the server will never ask you again about this password for the guest ID. So here I'll just store this password in my local setup. Okay. Then this server now just start to download all the packages about the IsoGSM to the local server here. Alright, so now the download process is done. So after download, you can see this the IsoGSM directory is this directory is created, and the every components are downloaded in this directory. Okay, so in the CVS version, maybe you can starting the download by the CVS cod install, and running the install. Maybe the system will ask you about the institutions and the components and resolutions or compilers or the anything else. But for my system, in this SPN server system, I'm just put on the entire the model packages, and now we have to 3 different processes are required to install this model. First, we have to install the library. Here the libs. Okay, this is the first step for the installing the library, and then we'll move to the GSM for the installing the source code. Then we'll move to the GSM learns for the model run. Okay, so in this version we need 3 steps for the install and the model run. Okay, so libs, source code, GSM, and the GSM learns. Okay. Okay, so now we have this downloaded the IsoGSM packages. So let's first start for the install this model's code. Okay, so first thing is installing the library. So let's move inside to the libs, and you can see all these components. So for the installing the library, first thing is the modify this configure libs. This is the configuring script. So let's check the inside of this configure libs. Alright, so here you can choose the institutions and machines, nicknames, compilers, and the march for the pedal job and the other setups. So all these things are we can set all these things for the predefined directories here. Predefined setup. That is, let's move again. This is the downloaded packages, and inside of the DEF, the defined directory, here you can see the sysvars diffs. This is the system variables and the defines file. So let's check these things. So like here, this is kind of the like a preset for the multiple platforms and multiple the compilers, the something like that. So because I'm using this isotope 2, you can search in this way for first the Fortran compilers are preset here in the isotope 2. The Fortran compiler is set to the MPIF90, and this is the LUMS compiler is also set for the MPIF90 in the isotope 2 system. So if you are in my system is called ROSes here, so I just added the everything in this part for the ROSes. So if you are not the user of the isotope 2 or isotope 3 or ROSes or guns create, so if you have some other nickname, then you have to add your machine's entry in this system variable define files. Okay, and okay, so the MPICH directory path is also specified here. Okay, but so for example, this is the kind of the CVS setup for the isotope 2, but in my case, for example, I'm using the MPICH 2 for the MPICH. So in my case, I have to change this part, the MPICH directory for my system. Okay? So I think that fundamentally, if you're the CVS setup, if you download it and install and run the CVS version and it work properly, then maybe you don't need to change anything inside of these system variables. But your system in your testing system is not included in these system variables. Maybe you have to add your system entries in here, or even for just like me, even your system like isotope 2 itself is already included in this system variable file, but you want to use some different setup for the default settings, then you can modify this machine identified files here. Okay, so right, so the other setups also you can this is for the MPI runs, and the other for this is header for the batch job schedulers, and the other things are also you can set up. Okay, all right, so I modified. So before installing the library, this is the actually the first step before the installing. Check your system and check these system variables in the defined directory, and make sure your system and your setup is properly specified in this file. Okay. Now let's move back to the library. Then now let's see this configure libs. So I choose the machine type for the Linux. You can see some presets, possible available options are specified in this commented lines here. So just left for the deadlines. And nickname for the now I'm using the iStop 2 and using the compiler for the Intel, and for the MPI I'm gonna using the MPI. Okay. And after modifying this configure libs, now we have to kind of apply all these modified factors and make them do the configuring before they compile. So that's simply run this configure libs script. Okay. Then the script will execute it, and we can see here. We can see some things are created, like I get library bars, the headers, system bars, seed, and machine.h, and now we have the makefile. So this is configuring, and after configuring, now we move to the compiling. The compiling is using this command, the make. Okay. Okay, so this is end up the compiling for the library. So let's check what has done. So if you want to check this library compiling is really kind of properly completed or not, move to the lib directory. Okay, so inside of this lib directory, you can see now this is the time. Now is 15:07. So just before I result again with the time. From here to here is the just created the items. Okay, so what exactly we're gonna use for this model installing is first thing is this w3lib.a. This is a library file. This will be referred during the source code compiling. And this is for the related to the writing or the reading some files which is written in the grid format. And the rib-encode-u.a, this is for the libraries for related to the encars, encode graphics or something like that. And the model-lib.a, this is will kind of mostly referred in the source code, and this buffer.a file is also the library. So this you can find this .a files in here. Then you can think this library compiling is normally the normally executed and normally terminated. Okay. Okay, so this is end of the library compiling, and the next step is compiling the source code. Okay, for the source code compiling, let's move to the GSM directory. This is the directory contains the source code. Alright, so now we have the configure model script. So this is the configuring the source code. So let's first modify this configure model. The next step is actually the same what we did in the libraries, modifying this script and run this script for the configuring, then make for compiling, right? So okay, so the first thing is specify the model, because we can choose here because this GRSM system is some kind of the integrated system. So we can choose the model for the GSM or RSM, or sometimes for the coupled model system we can choose here. So in our case, our model is the global spectrum model GSM. So we put this here, and here we have to specify the library directory, which is just before we the directory just we compiled. Okay, so because we set I set these libraries in here, SGSM and this. So please make sure this library directory is correct for exactly what we installed. And this is the model defined directory. So here in this defined GSM directory, there is some kind of multiple directories for this the different setups. So simply, this is for the related to the resolutions. So the first 62 means the horizontal resolution. This is the T means the T62 resolution for the horizontal, means the triangular truncation for with the 62 waves, and the K28 means the vertical layers. So vertically, we're going to use the 28 layers in the vertical projections. And the MPES means the total CPUs, the total processors, what we're gonna use in the model run. So in IFOC system, I'm gonna use the 12 the CPUs to use the one single node. And this n column means this is the related the numbers for the MPI, because the MPI kind of the decompose this models domain, and the pick one the decomposed domain to the each the single CPUs. So this is the number means how many columns for the domain decompositions. Simply very theoretically, we think the small number of the n column is proper for the higher efficiencies in the multiple processes. But but yeah, maybe you can do some sensitivity tests if you are really do some kind of the long-term simulations. But usually starting for the n column with the number 2 or 4, it depends on some systems and depends on your the model setup. So yeah, fundamentally, we can simply think the smaller number of the n column is kind of have some advantage for the high efficiency, high calculation efficiencies. But just I recommend do some sensitivity tests for the computing cost check. Okay, so here I'm gonna just use the n column with the number 4. And March, this is MPI. This means use the pure MPI system for the multiple processors. Okay. Okay. After the modifying this configure model, just run this configure model for the configuring. Okay. So then you can several files just created by configuring. At this time, because we are doing all these things for the semi-Lagrangian version of the IsoGSM, so you can check this define.h file. This is some kind of the option set for the compiling the source code. So then you can search the NISLQ. This is the option name for the semi-Lagrangian. Then you can see these three different options. Defining the NISLQ, and this is the define. The NISLQ itself is the non-iterational semi-Lagrangian for the Q, and this Q includes the vapors and the hydrometeors, and also for the stable water isotopes too. And so first turn, if you really want to this semi-Lagrangian, please make sure this NISLQ is turned on with this define. And the second is there is two different way we can consider this semi-Lagrangian advection. One is the monotonic advection, and the other thing is the mass conserving advections. What Henley did, and what I checked, I think at the current stage, this mass conserving the semi-Lagrangian shows some advantages for the low pressure system is affect some area. So when we have some the pressure change is dominant, or it should be included, then this have some kind of advantages to calculating the atmosphere. So yeah, I recommend using this mass conserving the semi-Lagrangian. And this physics option is actually the original version, which is created in the Grimm's model. It's simply actually the this NISLQ physics just working for the remove when the semi-Lagrangian is turned on, just remove the negative values to replace the negative values to the zero. It's a simple, but maybe after we can some clean up all these things. But at current version, just I just make these options just can be appears in this defined at age. So if you do not want to using this semi-Lagrangian, means just spectral calculations for the all the Q variables, then you can just change all these things to the defined to the undefined. Alright, so if you do all things in like this way, this source code we're gonna not use, will compile with the spectral calculations for the Q advections. Right, but you put these things with the define, then means this compiling processes will go with the semi-Lagrangian version. And for more specified, more clearly, if you want to return, when I checked in my system, at this stage, right after the configuring, modifying this define.h to turn off the semi-Lagrangian, it works. But for more clear, the turning on or the turning off this semi-Lagrangian version, I recommend changing these options inside of this define directory. Okay. So inside of the model configuration, so you can see the options for the dynamic options or the depending or the physics options or something. So this semi-Lagrangian option is now stored in this disk. So here, so if you are changing, turning on, define or undefine these options before configuring, please just changing these options, define or undefined, then move to the source code and configuring. Then this configuring process will read the model config, the header files, then apply the everything into this source code defined.h. Alright, so simply if you want to turn on or turn off, or the other options for the physics or dynamics options, the safe way is modify the everything inside of the defined directory, then check everything is correctly modified, then return to the GSM directory for the source code, then do the configuring by running the configure module. Alright. So after configuring, we can see now we have the make file here, and we're gonna do the compiling with the options for the make. Okay. It takes some time. Okay, so now the source code compiling is just the end, and now let's check this process is really properly completed or not. It's just simply we can see inside of this bin directory. It's a binary directory. So before compiling, actually this binary directory is empty, but after successful completions of this compiling, we can see some .x files. These .x files are the executable file for the model, and here in our case actually we're gonna actually use this file, the forecast running the executable file. This is the model itself. All right, so when you can see in all the .x files in the binary directory, then we can check and think the source code compiling process, the source code install process is normally done. Okay, and actually this is the end log of this our compiling. If there is some problem, maybe the compiler will stop at a certain stage and return some and give some complaining about the compiling processes. Then you can move or check each component and make some modifications or the corrections, and then you can continue the compiling process with the command of make. All right. So now the installing the source code is done here. The next step is run the model. Okay, to our next step, to run the model, we're gonna move to the GSM runs. So it's the first thing is configuring, and during this configuring, this script will create the actual run script. So before we have to check this configure SCL, this script we see inside, and please make sure this is the directory for the source code, and starting from the current working directory and searching for going up to the upper levels and search the GSM directories. Okay. Actually, CVS version is quite different. In the CVS version, we have to specify all the absolute path, but just for the convenience, I slightly changed this part. So if you have some confusing, just don't worry about that. Just specifying the absolute path for this section, absolutely it works. So if you have some different the structures for the directories, then maybe using the absolute path is much more convenient without any confusion, right? So actually here we do not have any parts for the modifications. We're going to bring out, and we'll do some. Now we'll make the run script. So in our case, I'm gonna make this GSM run script. So it's this is how to create the GSM script, the configure script, and one space and GSM. Then this this command will create the GSM run script. All right, and now we can see we have now GSM. So check this the multi-process the parallel the process numbers and node number we can check here, and this is run name. This G000 directory will be created, and every output will be stored in this directory. This is for the other options. Now our setup. Now I'm just using using this default setup for the test run. So now let's run this model. Here, submissions for the GSM. All right. Okay, this is the run directory. Now this is just created, and inside of this directory now they're always running. Those are our the output, the sigmas and surface. Now we set just for the 72 hours. So now it's gonna moving to the 24 hours and 48 hours. Now 72 hours. Okay. And my working is just terminated. Okay. Okay. So now we have all these files here. Simply, this is all. Now we have the PGV file for the pressure levels and the surface files too. So this is very simple. The instructions for the test run. So now we, if you just reach it at this stage without any troubles, then you can now use the install and run the semi-Lagrangian version of the IsoGSM. Alright, so if you have any questions or troubles, or if you have some recommendations for this the SVM version of this IsoGSM, just please never hesitate to contact me. So send me a mail, then I will apply every your opinions into this SVM, the source code system. Alright, thanks for the watching this video, and hope you can successfully do all these processes. Alright, thank you. Goodbye.